Welcome to UVU CS3060 Lecture 1.5, where I demonstrate some issues you experience with multiprocessing concurrency. So let's get started. Here I've logged in to the terminal and I'm ready to go ahead and start entering code. Now, as discussed in the regular slides, the thread that we talk about in a multiprocessing system is a series of instructions that are executed on the CPU. But the operating system also provides threading where it is slightly different than the way CPU represents them. Threading, from an operating system perspective, is like a process, except for the threads in a group all share the same memory. And what we're going to do is we're going to create two threads and let them try to modify the same memory and see what happens. Well, let's say that I don't understand how to do threads. So I'm going to go ahead and check to see if there is anything using the apropos. And I'm using the -a switch so that any term has to include both. That has something about threads and about create. I want to see if I can create some threads. Let's go ahead and do thread create. And in thread create, we see there is a man page for actual pthread create. So let's go ahead and take a look at that. man3 pthread create. There's a little difference between the 3 and the 3 POSIX section when it comes to pthread create. So we're going to use this pthread create function. To do so, we have to include the pthread.h header file. Pthread create takes 4 parameters that we'll use. The first one's important to us. It is a thread handle, so I'll go ahead and create it. But also, it's important to realize we have to use a compiler option, -pthread, to make this work. Well, let's go ahead. Oh, and also, for pthreads to work properly, I need to implement the pthread join function. I won't go into the man page for that right now. We'll talk more about threads later in the semester. So let's go ahead and create my source file. I, of course, want to include standard I/O because I plan on using printf, but I also want to include pthread.h. I'm going to create a global variable called num. And then I'm going to go ahead and create my main function. Won't use argc and argv this time, but I'll still put them in here for completeness sake. I need to create 2 thread handles. So those were pthread t. We'll call the first one thread 1 and the second one thread 2. I want to initialize num so that it has a value. Don't want to leave it undefined. I am then going to call pthread create. I'm going to pass it a reference to thread handle 1. Don't need any initializers. Go ahead and pass it the function, and I'm going to call this inc_num. I haven't created the function yet, but I will shortly. And then null. And we'll go ahead and create another one, but this time it's going to it's going to use the second thread handle. Now that I've created my threads, my main function can go ahead and perform pthread join. And it's going to use thread handle 1 and we'll pthread join to thread handle 2. And when we're done, we will printf to show the value of num should be %d is %d. So it should be. Let's go ahead and do this 2 threads. Each thread will do it 1,000,000 times. So 2 million, and then the actual number is num. So we need to create this increment num function. So let's go ahead and create a thread function. Now the thread function must take a very specific signature that I'm going to use here, but I'm not going to use the signature's values at all. All I want to do is create a loop. I is equal to 0, I is less than a million, I plus plus. And all this function is doing is incrementing numbers. So num equals num plus 1. There. So this main function creates two thread handles, initializes num to 0, and then creates two threads using our incnum thread function. It then waits for those threads to finish and then prints the values that comes out of that. Now, something to note here is both threads will be executing at the same time, possibly in different processors. Regardless, each thread is going to try and increment num by 1. Num starts out at 0. If two threads try to increment num by 1,000,000, we should get 2 million out of this. So I'm going to go ahead and save this and quit. And making sure that I'm using the pthread flag to compile with, I'm going to make race. All right, and we run race. And we can see that while it should be 2 million, it is actually 1,045,000. So for some reason, we lost 954,000 increments somewhere in there. And we can also see if I run it multiple times, I get different values every single time. This is called a race condition. What's happening here is both threads are trying to modify num, but only one of them is being successful. The other one, its increment gets thrown away, if you will. A race condition is very common between threads when memory is being shared. Now, there are ways to fix this. We have a very nifty little function. Let's go ahead and use apropos mutex lock. And, oh, I forgot the -a switch. Shame on me. There we go. That makes it a little bit easier. So if I do man pthread mutex lock, I can see that there's a function that will actually provide mutual exclusion between threads. And it needs to have this pthread mutex t, which can be found by initializing. So if we do man pthread mutex init, we can see that there's a function that allows us to initialize, or we can just simply use this default initializer here. So let's go ahead and add this to our code and see if it makes a difference. So I'm going to modify this. Now I'm going to create a mutex. So let's go ahead and pthread mutex t. We'll call the mutex mu, and we'll use the static initializer, pthread mutex initializer. And then we will pass this mutex into both threads. So now what we want to do is we want to convert this pthread mutex t back into its proper type. And we want to perform a pthread mutex lock on our mutex. And then pthread mutex unlock on our mutex. And what this does is when one thread locks this, the other thread can't actually come in here. If it tries to lock at the same time, one of the threads will win the lock and the other one will have to wait until the first thread unlocks that mutex, meaning that this increment of num should only happen once at a time. We should actually have isolation here so that each thread does not overwrite the other thread's value. Well, let's go ahead and save this and see if it builds. It's built successfully, so I'm going to run race, and you can see the difference is perfect. We actually get 2 million out of this. There are many ways to resolve race conditions. I've shown you one. We'll go into more detail on how to manage race conditions and how they come about in a later section.